Greetings, fellow soil stewards and garden enthusiasts. Welcome back to the Humus Heritage, where we dig deep into the living mysteries beneath our feet. Today we're embarking on an extraordinary journey into a hidden realm that exists right under your garden beds. A microscopic universe so intricate and powerful that once you understand it, your entire approach to gardening will transform forever. Imagine a secret, microscopic highway system beneath your garden, tirelessly working to nourish your plants. This invisible network, a fungal wonder, holds the key to unlocking unprecedented growth and resilience. We're about to pull back the curtain on this underground world and show you exactly how to invite these incredible allies into your soil. When you look at your garden soil, you're seeing only the most superficial layer of an underground metropolis teeming with life. Beneath that surface exists what scientists have dubbed the Wood Wide Web, a terrestrial communication and distribution network that rivals anything humans have engineered. These fungal networks are composed of microscopic thread-like strands called hyphae that weave through soil particles, creating a living fabric that connects plant roots across vast distances. A single teaspoon of healthy garden soil can contain miles of these hyphal threads, working constantly to facilitate nutrient exchange, water distribution, and chemical communication between plants. You know, this isn't science fiction or garden folklore, but it's actually a documented biological reality that's revolutionizing how we understand plant health and ecosystem function. The difference between soil with robust fungal networks and depleted soil is as stark as comparing a thriving city with functioning infrastructure to an isolated settlement with no roads or utilities. At the heart of this underground kingdom lies one of nature's most elegant partnerships, the mycorrhizal association. These specialized fungi have been collaborating with plants for over 400 million years, long before flowers existed or dinosaurs walked the earth. The relationship works through a beautifully balanced exchange economy where both partners benefit immensely. The fungal hyphae extend far beyond where plant roots can reach, acting as extensions of the root system itself, sometimes increasing a plant's absorptive surface area by up to 1,000 times. Through these hyphal networks, fungi deliver water and essential nutrients, particularly phosphorus, nitrogen, and various micronutrients that remain locked in soil particles and unavailable to plant roots alone. In exchange, plants photosynthesize sunlight into sugars and carbon compounds that they willingly share with their fungal partners, feeding them through their roots. This isn't a casual arrangement but an intimate biological integration where certain mycorrhizal fungi actually penetrate root cells, creating specialized structures for nutrient exchange. Plants growing in fungally rich soil display noticeably more vigorous growth, deeper green foliage, enhanced flowering, and remarkable resilience to environmental stresses compared to their counterparts struggling in fungally depleted earth. Plants don't passively wait for fungal colonization but actively recruit their underground allies through sophisticated chemical communication. Through their roots, plants release compounds called exudates, including sugars, organic acids, and specific signaling molecules that essentially advertise their presence and willingness to partner with compatible fungi. Different plant species release different exudate profiles, attracting specific fungal communities that best serve their needs. However, this delicate recruitment process can be easily disrupted by common gardening practices that most of us have been taught to consider essential. Tilling and digging physically tear apart the established hyphal networks, destroying years of fungal infrastructure in just a matter of minutes. Synthetic fertilizers, especially those high in readily available phosphorus, actually discourage plants from investing in fungal partnerships because the easy nutrients make the relationship seem unnecessary from the plant's perspective. Fungicides obviously harm fungi directly, but even broad-spectrum pesticides and herbicides can damage these beneficial organisms. Perhaps most surprisingly, leaving soil bare and exposed deprives fungi of the continuous carbon inputs they require for survival and the living root systems they need to partner with. The good news is that attracting and nurturing beneficial fungal networks requires working less rather than more, allowing natural processes to flourish without constant disruption. The single most impactful change you can make is adopting no-till or minimal disturbance practices in your garden beds. Instead of turning soil each season, just add organic amendments and compost to the surface and allow soil organisms to incorporate them naturally. This preserves the intricate high-fall architecture that took months or even years to establish. Ground cover is equally critical, whether it's through living cover crops during the off-seasons, perennial plantings, or generous applications of organic mulch. Fungi, in particular, really thrive when you provide woody, carbon-rich materials like wood chips, shredded bark, pine straw, or even autumn leaves as a top dressing. These materials feed saprotrophic fungi that break down complex organic compounds, while also creating the ideal moist, protected environment that mycorrhizal fungi need to flourish beneath. When planting new areas or working with degraded soil, you can jumpstart fungal colonization by incorporating high-quality compost that's been properly aged to favor fungal over bacterial dominance, or by using commercial mycorrhizal inoculants appropriate for your specific plants. The most powerful strategy, honestly, involves establishing plant diversity in your garden, incorporating a mixture of annuals, perennials, native species, and nitrogen-fixing cover crops. Each of these supports different fungal communities and helps create year-round, living root presence in the soil. Once established, a thriving fungal network transforms your garden into a resilient, largely self-maintaining ecosystem that requires decreasing inputs while producing increasing yields. These underground allies provide drought insurance by dramatically improving your soil's water-holding capacity and extending your plant's reach to moisture reserves. They offer disease protection by outcompeting pathogenic organisms and producing antibiotic compounds that suppress harmful microbes. The extensive high-fall networks bind soil particles into stable aggregates that resist erosion, improve drainage in heavy soils, and increase moisture retention in sandy soils. Perhaps most importantly for our changing climate, these fungal communities sequester significant amounts of atmospheric carbon deep in the soil through their own biomass and the stable organic compounds they create, turning your garden into a carbon sink rather than a source. As you implement these practices, observe your garden carefully throughout the seasons, noting improvements in plant vigor, reductions in water requirements, and the gradual enrichment of your soil's structure and fertility. We invite you to join this underground revolution and become active participants in regenerating the living soil beneath your feet. If you found this journey into the hidden world of fungal networks valuable, please subscribe to the Humus Heritage and share this video with fellow gardeners who are ready to work with nature rather than against it. Drop a comment below sharing your own observations about soil health in your garden, and let's build a community of soil stewards dedicated to nurturing these invisible allies. Until next time, keep digging deeper.